Hello everyone and welcome to my channel. Today I'm excited to share a special recording from a live session I conducted in the last week of January 2025 with the Persian Power BI user group hosted by Vahid Doustimajd, who is a Microsoft Data Platform MVP and the user group leader. This session dives into the intricacies of handling large semantic models in Power BI. We start with the foundational concept of semantic layer and its role in data projects. We then talk about some common challenges and some advanced strategies such as partitioning, incremental data refresh, aggregations, and different approaches in aggregations in semantic models in Power BI. So let's get started and have a better understanding around large data models in Power BI. Thank you for tuning in, and special thanks to Vahid Doustimajd again for the opportunity. So without any further ado, let's get to it.
Good day, everyone, and welcome to another online session at Persian Power BI user group. My name is Vahid. As the organizer of this user group, I want to say thank you for joining us today. We have a great speaker today. Sohail is with us. Hey, Sohail, how are you, mate?
Hi, Vahid. Thanks for the opportunity.
It's great to have you back again in this user group.
Thank you.
Today, Sohail will talk about dealing with large data models in Power BI, which is one of the most common business question and issues in many organizations. Sometimes you need to deal with the big data, very large data set and models. And Sohail will show us some of those tips and tricks to be able to keep our performance, keep the report performance high, and reduce using too much CPU and RAM. So I can't wait to learn more from you, Sohail. Just a little bit, a few things I want to share here. We have organized a good event which will be held on 7th and 8th of March, which is the Fabric first Persian Fabric and Power BI event. Let me share my screen for a sec. How can I do that here? Share your screen. I think I can share it here and add it to the screen. Yep. So this is the website there. I will send it in the chat, the link on there. So 38 days from now, this event, this free online event will be started. We found two great keynote speakers for this session. We have two rounds of the session. First day will be English session, and the second day will be Persian. So in Farsi, people will talk there. So Muhammad Ali, the director of the PM in Power BI, will join us and will show some of those new features in Power BI. So stay tuned, attend that meeting, because I'm pretty sure Muhammad will show us some of those new features. And then we have Reza Rad, who will show us about and tell us about the Fabric, new things in the Fabric, and how you can transform from Power BI user to a good Fabric user. So that was the only thing I wanted to add here. So over to you, Sohail. Let me
thank you very much.
In here. Yeah, go ahead, mate.
Okay, all good. Hello, everybody, and thank you for taking the time and joining today's or tonight's session. Hello, good morning, good afternoon, good evening, depending on wherever you're connecting from. So in today's session or tonight's session, we will discuss the hot topic of dealing with large data models in Power BI, semantic models. At the beginning, I will start introducing myself a little bit for those who don't know me, and then I will start discussing some basic building blocks about business intelligence as a whole, not only Power BI or Microsoft Fabric or whatever, the entire business intelligence processes, and then I'll gradually move towards semantic models in Power BI and dealing with large semantic models. I hope that 1 hour will be enough to cover everything. Without further ado, I just would start. Okay, so everybody, can see my screen now. and I already talked about the agenda of today. So, welcome and introduction, understanding business intelligence systems, challenges with large data models, optimizing large data models in Power BI. I will give you some tips, and I will share some of my experience along the way, and questions and answers. During the session, if you have any questions, please leave your questions in the chat box, and I'm sure that Wahid will take it and
Yeah.
if either answer the question or just ask me to answer the question.
Yeah, feel free
So,
if you want to raise. Sorry for interruption. If you have any question, just drop it in the chat, and I will ask that in a good moment between some slide. So I will keep my eye on that area.
yeah, great. So, my name is Sohail Bakhshi. I'm a Microsoft MVP. I'm an author, blogger, and consultant. You can find me on my website, my weblog, YouTube channel, LinkedIn, Blue Sky, and Twitter, which are on the screen. If you want to take a screenshot or connect with me, I'll be more than happy to have you in my circle. So let's start with understanding business intelligence systems, and I will start with an overview of business intelligence or BI processes and the role of Power BI as a semantic layer. And I will explain what semantic layer means and how it what is its place in the process. So if you are here, you are definitely dealing with multiple data sources, and you want to integrate all of those data sources into a central storage to centralize everything into one, to have everything into one storage. Those data sources can be text files, can be databases, can be spreadsheets, sensors, file system, cloud sources, and whatnot. And we will use ETL, extract, transformation, and load, or ELT, extract, load, and transformation, to centralize all those data into one single repository. The reason for that is that it gives us more flexibility and it is easier to deal with the data when everything is in one place. The next step is usually that we take some other ETL or ELT processes, depending on the landing zone of the next step, which can be a data warehouse or a lake house. So depending on our architecture and the scenario that we are working on our data platform, we may have data warehouse or a lake house. The difference between the data warehouse or lake house and the centralized storage is that within this transformation from the centralized storage into a warehouse, we transform the data in a way that is more optimized for reporting and analytical purposes. As you know, transactional systems are very hard to work with, especially if you want to build some analytical reports. I'm not talking about ad hoc reports or today's sales or something like that. Those are just the reports that you may be able to get from the source system without any issues. But if you want to have an integrated, let's say I have finance, I have inventory, I have sales, and I want to have everything in a single place, and I want to analyze that data, then without having a data warehouse or a lake house, which is more purposefully designed for analytical purposes, it would be very hard and very expensive to run. The next line would be the semantic layer. So we add yet another layer on top of our warehouse or lake house, and it is called semantic layer. In this layer, as you see on the screen, the arrow is called process. We do not do a lot of data transformation in this layer. Rather, we process the data. For creating semantic layers, it is best practice whatever semantic layer we are talking about, it is best practice not to bring the entire historical data into the semantic layer, because its purpose is solely to support analytical reports or and for other analytical purposes, machine learning, AI and ML and whatnot. If we bring the entire history of data into the semantic layer, sort of the purpose of semantic layer will be defeated. Well, one purpose of it will be defeated. But what we do on the semantic layer, we take extra steps on top of a warehouse or a lakehouse. And one of those steps is we pre-aggregate the data. Imagine that you have a table with 2 billion records in your data warehouse, which contains 20 years of data. So 2 billion records, 20 years of data. And now we process that data into the semantic layer based on business requirements. First question that we ask from one of the first questions that we ask from the businesses is that how much history of data you require to analyze. Maybe 5 years would be efficient, maybe 10 years, whatever that number is. We tend not to bring the entire 20 years of data, 2 billion records in just one table into our semantic layer. Let's say for the business that we are talking about in our scenario, we only need 5 years of data, right? So you can imagine how significant impact it will have on the semantic layer itself. And we start pre-aggregating that data again based on the business requirements. Let's say that I want to analyze my sales or retail data based on the lowest granularity that I want to go down in my analytical reports would be at the month level or week level. So instead of having every single transaction per second or per minute, I now can aggregate or pre-aggregate everything into the month level or week level, whatever that level is. Or, for example, maybe we have 20 layers or 20 levels of product hierarchy, right? Maybe we do not really need to go down to the 20th level. Maybe the first 10 level would be enough for some of the analytical purposes that we are after. So that is very specific use case for semantic layer. I suppose this will straight away answer one of the very popular questions that we usually get, which is, okay, so what is the difference between semantic layer and data warehouse? Are they the same? Well, they are not the same. The technologies are different. The purpose is also different. In the warehouse, you can start, changing the data, updating and incrementally loading the data, and you have the full history of data in your warehouse, let's say 20 years of data. But in a semantic layer, you really don't need to bring all that information into your semantic layer. In the semantic layer, we are pre-aggregating everything. And then now we have a central area, which is the single source of truth for our visualization tools, whatever they are. It might be Power BI, it might be Tableau, it might be Excel, whatnot. You name it. There are a lot of visualization tools out there. So with that, what is the role of Power BI and SSAS or SQL Server Analysis Services? Power BI is coming from, the roots of Power BI are coming from SQL Server Analysis Services tabular model. Power BI and SSAS tabular models both are using Vertipack engine, which is an in-memory data processing engine. So both are playing the role of a semantic layer. Here it is. We are answering yet another question. Can I create a data warehouse in Power BI? Fundamentally, that question doesn't make too much sense. right? So the answer is technically no, because we are indeed creating a semantic layer. And that was one of the main reasons that Microsoft renamed Power BI datasets to semantic models, because they are actually semantic models. It is a semantic layer, keeping my data and the model structure within the semantic layer. Now, we are processing our warehouse and lakehouse data into a semantic layer, which will optimize, which is optimized for analytical and reporting purposes, pre-aggregated data for faster querying performance, better performance, driven by business logic and processes, as I mentioned, and improves query efficiency. It supports row level security and object level security, and it provides audit logging and compliance and supporting for regulatory requirements. What are other benefits of having a semantic layer? For the visualization, let's say I'm visualizing my data and now I'm gradually moving towards Power BI. In Power BI, these are the benefits. I am always working with a single source of truth as a data hub for my visualization. So my semantic layer in the middle is my single source of truth. So I can connect to a single semantic layer from multiple different reports for different purposes, both for different departments in the organization, asking various sorts of questions, querying the semantic layer, and so on and so forth, to enhancing the business agility and decision making. Right? I would stop here before I jump to the next one, which is the challenges of large data models. If you have any questions, I'm more than happy to pick up the questions right now.
Well, there are a few questions actually. I'm just reading them for you. Uh, Sahara asked about the tools examples in semantic layer. I just ask if she can add more details to the question. That would be great. But the question is, what are the tools examples in semantic layer?
Power BI semantic models, SQL Server analysis services,
Yeah.
Power BI report server, models that you build on your local report server, Excel, Power Pivot models in Excel. They are all semantic models,
Yeah.
semantic layers.
And then the other question Mohammad Reza asks is, do we save data in semantic layer, or is it just a save query or view?
It depends. We can do both, right? We can import or store a copy of the data in our semantic layer, or we can create a direct query. The correct term is direct query to the source system if the source system supports a querying language like SQL.
Yeah, perfect. Those two are the only questions for now. Okay. Thank you so much.
Okay, great. The next one, challenges of large data models. Look, I have put about 11 challenges here, and these are the challenges that I faced myself, and some of these are really hard to tackle, but there are many other challenges, so I'm more than happy to discuss if everyone in the call has faced some other challenges and to share your experience with everyone else and myself. So the first one is inefficient data model design leading to excessive memory usage and poor performance. Look, when we talk about Power BI semantic models or SQL Server analysis services, or in general, Vertipack engine, we are talking about in-memory data processing. So the amount of memory available to us is always a challenge. If we do not um, design our model in a way that it is the most efficient one in using memory, then we are in big trouble. And I've seen a lot of examples about that. Poorly designed or unimplemented incremental refresh, resulting in unnecessary resource consumption. I will dig more into more details about incremental refresh, but just to give you a very generic view, incremental refresh is that we do not load the entire table from scratch every time that we are refreshing our semantic model. Instead, we just capture the changes or a part of the data, right? A portion of the data. So if we are dealing with large data models, then having incremental data refresh sometimes is really, really inevitable. We must have incremental uh, data refresh. You may think, oh, I didn't put it in the slides, but you may think, what do you mean when you say large data models? What is the definition of large, right? So in Power BI or Vertipack engine, if the data model is designed well, we tend to move towards 1/10 of the data source file size or data size, right? So let's say if I have 10 gigabyte, and 10 gigabytes is not really big, right? 10 gigabytes of data in my source system, which I would like to analyze. That 10 gigabyte may be a proportion of 20 years of data, right? Maybe it is only 5 years of data. It is 10 gigabyte. We tend to tackle 1/10 of 10 gigabyte in our semantic model, which would be somewhere around 1 gigabyte mark. And 1 gigabyte is not large, right? I've dealt with semantic models as large as 20, 30 gigabytes in size in just one semantic model, right? So just keep that in mind. And improperly designed or missed user-defined aggregations or custom aggregations. I will cover that as well if time allows. And leading excessive memory consumption. And aggregations, as I mentioned earlier, is that where we pre-aggregate the data in the semantic layer instead of recalculating everything on the fly again and again. Loading the entire historical data that I already discussed and mentioned many times. High memory consumption during data refresh processes due to maintaining the current data model while loading new data. Have you ever thought what happens when I start refreshing a data model and how come my reports are still working? How is that possible? We start refreshing a table, the data in a table, which I will show you later, right after this slide, that we literally truncate the data, we delete the entire data, and we reload the data again into the table. So how come my reports are still working? So I am connected to the same semantic model that is refreshing. So here's the thing. Power BI takes a mirror of the semantic model and refreshes that. And at the same time, we have our main semantic model intact, right? That's why the reports are working. And that's why this is very important to just think about it. You have to consider 2x of the size of the current semantic model when it is starting refreshing. So if I have a semantic model of 1 gigabyte, when I start full refresh overnight or right now on demand, it most probably consumes 2 gigabytes of memory, right? So that is very important point to notice. Managing composite models with regular and limited relationships in many cases is problematic and leads to poor performance and poor security, especially on RLS and OLS designs. Handling large fact tables with many distinct values resulting in bloated dictionaries. Here's the thing. Fact tables, in fact tables, we would like to see numbers, numeric values, right? Not really large texts. But the other thing that we would not like to see are the columns with distinct values or a lot of distinct values. Vertipack engine uses column store indexing mechanism, which looks at the columns instead of rows and reduces and removes the duplicates. Let me give you an example. Let's say I have a table. That table has only one column, and that column has 2 billion values or 2 billion records of data, right? The data type of this column is Boolean. It is true or false. So I have 2 billion trues and falses, combination of trues and falses, right? The X velocity engine and column store index sees only 2 values. But here's the thing. It records everything into something that is called dictionary, right? So the more distinct values we have in our columns, the larger dictionary, because it records all the addresses, all the pointers, all the values, and I have 2 values here, and here, and there. Okay, so that is another thing to be mindful about. Misunderstanding the processing options at the model level, table level, and partition level, leading to suboptimal refresh strategies. When we are dealing with large semantic models, it is very important to understand processing options. Processing a table or a data model is a technical term for refresh. When we go into Power BI service or Microsoft Fabric and we refresh a semantic model, we are processing the entire semantic model. But do we really need to process the entire model, or just one table needs to be refreshed? If we are talking about one table, or the requirement is one table, then perhaps the setting in Power BI service is not our best friend. The next one is overlapping data refresh scheduled, causing conflicts and disruption in processes. As I mentioned earlier, every single semantic model refresh requires somehow 2x the model size itself. And just think about it. You have 10 semantic models and running perhaps at the same time, or some of those semantic models are overlapping during refresh. There you go. You're out of memory and it will lead to disruptions. Performing complex data transformations in Power BI itself instead of at the data source, right? Remember the previous slides when we were doing some data transformations. If you are dealing with really small size data model, in many cases, nobody really cares because it doesn't make any trouble for you, right? So I have an Excel file and a very small size SQL database, and I connect from my Power BI to to SQL and database and start mixing and matching and creating my semantic models. And after that, my report. Who cares? But if I am dealing with large data sources, you would really need to care about it. It is not a simple thing to tackle. Memory limitations and licensing constraints. So, with different levels of licensing, including Power BI Pro, Power BI Premium per user or PPU, or fabric capacities. With every single one of those, we have memory limitations, right? We have to be aware of that when we are designing our data model, right? One of the first questions that I ask when I start a project with a customer is that, okay, what is your licensing, current licensing? Do you have PPU? You have Power BI Pro? Because the constraints and limitations are different. Any questions before I jump to the next section?
Well, there was some questions, and you covered them during your presentation, so I won't ask him because you perfectly covered them.
Great stuff. Okay, the next one is one of my most favorite topics, which is star schema. No brainer that I wrote 2 editions of a book about the star schema and data modeling, right? Here we are. Okay, so poor data modeling leads to poor performance. One of the questions that I usually ask is, what is the best data modeling approach? Or is there a best data modeling approach? The answer to this question is that honestly, there is no one size fits everybody, right? So I don't think there is a best data modeling approach. The best is that you understand your customers' requirements. If you are working in-house and in your organization and you are serving other departments, it is important to understand their requirements, understand their problems that you are going to solve within Power BI in data modeling, right? And then take the best approach. So many people talk about star schema. Let's scratch the surface. What is a star schema? Star schema is when we design our and transform our source, the data that is coming from our different source systems, into facts that is surrounded by dimensions. If you look at this image, it somehow looks like a star, right? But in fact, I have not seen a lot of full star schema in my career because it is not something uh, easy to tackle, right? So one fact in the middle and surrounded by dimensions. You usually have more dimensions and some other facts, and there are some other different approaches, different types of facts that you need to be mindful about. Next question is, shall we always follow star schema or denormalize and follow a flattened design? The answer is, it depends. It really depends on uh, your scenario. What about snowflake schema? Okay, so now things get a little bit more spicy here and hot, right? So snowflake is when you do not have a complete star schema. You know, star schema and snowflake schema, both of them are coming from dimensional data modeling, which we have facts and dimensions. Each dimension, which is a table, has its attributes, which are the columns of my dimension, right? And the facts are the columns of my fact table. I have a fact table that has facts, and a fact is an event that happened, that has happened, and um, it is measurable, something like sales, right? Sales amount. So is it bad? The answer is no, it is not bad, right? So in majority of cases, we follow snowflake schema. We may have a dimension that is linked to another dimension, and that dimension is serving a fact table or a couple of fact tables. Next one, the next topic is incremental refresh. Before I jump to the incremental refresh, are there any questions? If not,
No,
I just move
nothing at the
forward.
moment.
Okay, great. Remember that that I said earlier, that whenever we refresh a table or a data model, we are basically truncating the entire table. Let's say I have table A. Whenever I refresh this table, I am literally truncating the entire table or the data. So the table is empty. And then I start loading it from scratch. Now let's think about it. I have a really, really large fact table, which perhaps takes more than 2, 3, 4, 8, 10 hours to refresh. It doesn't sound right to me to do a complete or a complete refresh, which is truncate and refresh. Now let's see what incremental refresh has to offer. Now let's have a look at table B here. In table B, I have 3 different parts. And you can imagine of a table with 3 different parts, each part serving a different purpose. The real-time part, which highlighted in yellow, will be your real-time data. So you are connected to a data warehouse, and whatever is updated in the data warehouse, you will see that update immediately in your table, right? And this is so-called a hybrid table. It is only available in fabric capacities or PPU. The blue part is the part of data which is called incremental range, which we specified that this is the range that I want to be considered at the refresh time, right? So whenever, let's say I'm refreshing this table just once a day, overnight, right? So the only part that is going to be looked at for refreshing the data would be the incremental range. And what is the historical range? Historical range, the data that is in historical range remains intact. So it does not get deleted. So we have that without any changes during the time period that the data um, passes its retention period. Let's say when I'm thinking about importing or getting 5 years of data, that 5 years is a moving frame, right? So next year, we will have some partitions or some data that will be removed from the historical range, and it moves forward. So now when I refresh, hit the refresh button or schedule refresh, it will only refresh the incremental range. Let's take a little bit um, deeper into this topic, and let's forget about the real-time data for now. So as you can see on the screen, we Power BI creates partitions, right? And these partitions, let's say I want to keep 10 years of historical data into my partitions. So 10 years of data is the duration of the data that I want to keep and analyze. And only 3 months of data is incremental partitions. What happens in real world whenever we refresh that 3 months of data will be truncated and loaded. Now, what if that 3 months of data is a lot of data? In real world scenarios, one of the businesses that this scenario applies to is logistics. Let's say that you are running an international business, logistics business that delivers goods internationally, right? So you just purchase something from Europe, and it's going to be delivered to you in the next 3 months where ships, on across the ocean, right? It takes 6 months. Now, what would happen, right? Now, the next topic will come and play, which is change detection. I would say, rather than truncating and loading that 3 months of data, what if I have a mechanism that I can detect a change within the within my incremental range? Remember, only partitions in the incremental range will be considered at the refresh time, right? So the historical range will never be considered to be refreshed again. Okay, now I have 1 month of data which will be truncated and loaded. I still have the most up-to-date data, right? But the amount of data that I'm refreshing or loading from my source system is significantly smaller. Now, let me take one step further. What happens now if we detected a change in the historical range, and now are all the numbers that we see on in our reports uh, are incorrect? Remember the logistics example that I gave you? After 6 months, the goods are delivered. Now, perhaps the sales amount or the order date or delivered amount would be different. We need to capture those. But Power BI, as of today, and incremental refresh does not give you the ability to do it in an easy way. All of these things that I explained to you just before this specific change can be managed within Power BI itself, within incremental data refresh. If you set it right, Power BI will take care of your data refreshes. But this specific challenge is not available out of the box. Here's the good news. We can refresh partitions. Remember that I mentioned earlier, understanding different types of processes across model, table, and partition. This is one of the examples that we really need to think about understanding our processing options at the partition level. So let's say I've done all the change detection and everything is sorted. At the end of the day, a poorly designed incremental refresh definitely leads to excessive resource consumption and poor performance. So incremental refresh, if you get it right, can be the answer. Now, why incremental refresh is not the ultimate solution? Because there are some scenarios that incremental refresh would be really hard to manage or handle, or sometimes it is not even one of our options. One of them is large data volumes in incremental range. Let's say even for 1 month, the data that I am processing is very, very large, right? So perhaps we have to decrease the number of, decrease our incremental range, maybe at the daily level instead of 3 months, right? So we have to play with that. But this is a good challenge to have because we perhaps can fix it. The other one is prolonged data refresh leading to throttling or timeouts. Again, if we do not design our incremental refresh up to the business requirements and up to the standards following best practices, we probably get throttled and timeouts. Volatile historical data. If the historical range, if the data in historical range is tend to change a lot, that would be a real challenge to use incremental data refresh. Limited data source capabilities, for example, if the data source does not support query folding, then we are in trouble. Frequent schema changes. Okay, that is a very interesting topic by itself because look, we are dealing with a large data model in a semantic layer. What if the business requirements has changed and the business added just one column to the source table in my warehouse? What should I do now? You need to go through a whole lot of different processes and change management. Cross-partition aggregations requirements, something like rolling average across all data, the entire data, including historical, and every single change that happens in one partition, it must be accumulated in the other partitions, right? So that would be a really hard challenge to have. Non-date based data update requirements, something like when the update is required on something that is not date or data type, right? Something like a product hierarchy. When a product hierarchy changes happen, I want to an update happen. And dependency in chains across models. The word chain is a technical term which comes from composite models over multiple semantic models. When a semantic model A is calling a table or linked to a table in semantic model B, and that semantic model is dependent to semantic model A. So changes into any of those may not necessarily propagate to the next level of chain. Okay, so now I would like to stop here and pick up any possible questions. I'm conscious of time. We have only, I think, 13 minutes left.
Yeah, so there is one question from one of the people here. The question is, what happens if I need to change the model, bring in new field, for example? Do I have to refresh all again to have the historic partition?
Yes, unfortunately, yes, that is something that breaks the entire incremental refresh.
But when you load it once, after that, you don't need to do it. You can start the incremental refresh again.
That's correct. You need to do another first full refresh, which takes care of creating all the partitions for you, historical partitions and incremental partitions, and everything will go fine after that. So that is something related to change management. So you probably want to do that maybe during a long weekend or during the weekend or public holidays.
Okay, perfect. Thanks, mate. That was the only question.
Okay, now I give you the option to jump to perhaps to the end of my presentation or continue with the next topic, which is aggregations. I wanted to talk about aggregations because aggregations is another method that you can work with large semantic models and large data models. But I have some explanations on why all of these things are sort of happening at the end. I kept the best for the end. So I'm conscious of time. So what do you think? It will take somewhere around 15 minutes.
Yeah, so can let's do it. I was thinking if we can have it as another session to have you again here, because we love to have you again here. But it's up to you, mate.
Yeah, let me go quickly around aggregations.
Okay.
I've already explained the uh, meaning of aggregation. So we summarize the data into a higher granularity. So the table that you see on the left-hand side turns to a table in the right-hand side when we aggregate it, right? So this is the table in the left-hand side with 60,000 records, now turned into a table with only 38 records. If you look at the columns, the sales column and internet sales count or sales number of items that are number of sold items is count into another column. If you sum those values, you will get exact same answer. But would it be more expensive to work with a table with 60,000 or 60 million or 60 billion records, or 38 or 3,000 or 3 million records, right? So obviously the aggregated table would be much faster. And the next one was implementing custom aggregations. The custom aggregations is the aggregations that the developers implement, right? We do not, or we cannot perhaps use the aggregations out of the box available in Power BI. In that case, we need to handle data summarization and user navigation. To give you a little bit of sense around it. So look at that. I have internet sales that is coming from the internet sales table, and I'm summing the sales amount. And I also have a sum of sales, which is coming from internet sales aggregated year month. The internet sales aggregated year month is an aggregated table, right? In the expression at the bottom of the page, internet sales ag, I am looking at where the user is on every chart that uses these measures, and I identify the level that the user is at, and I navigate the user to use the specific measure that is built for that specific level. In the aggregation, I think it is a little bit complex without providing more explanation. Anyway, so, but user-defined aggregations or ag awareness is the out-of-the-box available mechanism in Power BI itself, the built-in feature that we just take care of the summarization, and it imports the data into the model and keeps the detailed table in direct query. So my fellow that asked a question in the semantic layer or semantic models, do we import the data or we just query the data? And I mentioned both is available. This is the answer to your question, right? So in aggregations, we have the aggregated table that is imported into the data model, the 38 records. But whenever the user is asking for more details, I go through a direct query and go to my SQL server, right? So instead of importing 60,000 records into my data model, I import only 38 records and answer all of the relevant queries, right? Now, another question. Does the data source influence the implementation of aggregation? Of course it does. All right. Now I'll go to the next one, which is different approaches of implementing user-defined aggregations. We have relationship-based, group-by-based, and hybrid approach. The relationship-based, as the name resembles, is when we are working with relational data sources, and the data sources obviously support a querying language. And for example, in this image, as you can see, the theme product is linked to sales aggregation, and that is there is a live relationship. So when I define my aggregation, I do not need to specify the summarization because the relationship will take care of that part. And I wanted to revisit the data modeling. I think I have to move over and just quickly tell you that the flattened design will specifically be helpful and necessary if you are dealing with big data, something like a Hadoop cluster that you're working with, you will add your dimension attributes into the fact table, right? So star schema is not going to work here, or is not suitable for this specific type of data source, because uh, um, all the joins are pretty expensive, and we want to mitigate every single join as much as possible. Next one is group by based implementation, and it is when we are when we are dealing with big data like Hadoop, or there is no relationship uh, between the aggregated table and the dimensions, like something like that, right? If you look at that, the dim date doesn't have any relationships to sales aggregation, but I have two columns that are in my aggregation table. For that, we set the group by in when we define our aggregation. The next topic is configuring large semantic models within Power BI service, right? Okay, this is a configuration available in specifically for semantic models. You can do it on the semantic model layer level, or you can do it on workspace level, right? But it allows the the models to go beyond the limit, the limit size. Who is this for? Unfortunately, or maybe fortunately, there is a reason for it that I will touch later today in a minute. It is specifically available for F64 capacities, fabric capacities, and or higher, and Power BI premium per user licensing plan. Why is it important? It is because, as I mentioned, it allows semantic models to exceed the regular size limits. Remember, at the beginning, I mentioned that different licensing have different limitations on semantic model size, and that is the regular size limit that I'm referring to. And it improves the performance by more efficiently compressing the data, and the segment size increases from 1 million rows to 8 million rows. Unfortunately, I do not have enough time to explain what segment is, but it is like when you are using a column store index, instead of loading 1 million rows and getting the distinct values of distinct values, you have a 8 million row chunk, and that chunk is called segment size, but there are much more in it. And this quick video, shows you how to enable semantic large data models in semantic models. So you go to the semantic model settings and just turn it on and click apply. It takes some seconds, depends on the size of your semantic model, obviously, and then it would be enabled afterwards. And large semantic model configuration. And why is it available only for F64 and PPU? The reason is that the size limit for regular semantic models, on premium capacities, premium or premium per user, is 10 gigabyte. This is the configuration that can only allow semantic model size increase as much as the capacities memory allows, right? So if you look at the this image that I took from Microsoft Learn, you will see that an F64 capacity gives us 25 gigabytes of memory in total for everything. That whatever we're doing in our Microsoft Fabric capacity, we have total of 25 gigabytes, while PPU, premium per user, is equivalent or comparable in terms of memory size with an F 256. And with that, that's pretty much it. I'm 30 seconds over.
Thank you so much. It was a great presentation. There is one question,
Of
Christian
course.
asked that one, and that's about would you recommend using the automatically handle aggregation or custom define aggregation? We know there is no one size fits all, but just like star schema, is there a recommended way of using aggregation?
Well, maybe I have I don't know, OCD or something, but I really don't like the automatic uh, mm, automatic stuff. I would like to have control over aggregations. So that would be my honest answer.
Perfect. Okay. Thank you so much. There is no other question. Again, thank you for sharing your time and knowledge and perfect presentation with us. I hope in the future we can have more session and pretty much all the people, there are more than 30 people watching us now, like this presentation. And for now, thank you everyone. See you soon. Thanks.
Thank you. Thanks, Vahid. Bye bye.